Hey everyone, welcome. Today we're going to crack the code behind pretty much anything that flies through the air. We're talking about quadratics, the math that's basically the engine for physics and trajectory. So let's get right into it.
You see this curve? That's a parabola, and its entire path is dictated by a quadratic equation. So what does that mean? It means if you can get a handle on the equation, you can predict how high that rocket will go, and you'll know exactly where it's going to land. The math we're doing today? Yeah, it's literally rocket science.
All right, here's our mission briefing for today. We're going to start with the why. Why quadratics describe the path of a projectile. Then we'll dive into part 1, the quadratic blueprint, where we build our whole toolkit. That's the theory. After that, it's your turn in part 2, your launch sequence, where you get to solve some missions yourself. And hey, don't worry if you get stuck on the launch pad. Part 3 is guidance from mission control, where we've got hints. Finally, we'll wrap it all up.
So what's the big deal with this specific type of equation? Well, it's all about predictive power. A single quadratic can tell you the entire story of an object's flight. We're talking its launch, its absolute peak height, which in math speak we call the vertex, and its final destination, the impact point, which, you'll see, comes from the roots of the equation. Okay, before we launch, let's just make sure we're all on the same page with our components. The basic building block here is called a polynomial. It's just a fancy name for an expression with variables and numbers, like 3x squared plus 5x minus 2. Now, what makes a polynomial a quadratic is its degree. That's its highest exponent. If that highest power is a 2, then congratulations, you're officially dealing with a quadratic.
All right, part 1. Time to build our toolkit. I want you to think of these next few concepts as the essential blueprints you're going to need to build and take apart any trajectory you come across.
First up is FOIL. It's really just a handy checklist for how we build a complex quadratic path from two simpler pieces. So let's say we have x plus 3 times x minus 5. We just follow the steps. First, x times x gives us x squared. Outer, x times negative 5 is negative 5x. Inner, 3 times x is 3x, and last, 3 times negative 5 is negative 15. Then you just combine those two middle terms, the negative 5x and the 3x, and bam, you get x squared minus 2x minus 15. You just built a quadratic from scratch.
Okay, so what if we wanted to do that in reverse? Well, that's called factoring. It's like taking the final flight path of our rocket and reverse engineering it to figure out its original launch settings. This is actually how we find some of the most important pieces of information, like where the rocket is going to land.
And here's how it works. For a quadratic like x squared plus 7x plus 10, it's basically just a little puzzle. You're looking for two numbers that multiply to give you that last term, 10, but at the same time, they have to add up to the number in the middle, 7. Well, what two numbers do that? 2 and 5. So it just factors out into x plus 2 times x plus 5. It's simple, but it's incredibly powerful.
Okay, red alert. I'm giving you a warning from mission control because this is a trap that so many people fall into. When you see something like x plus 3 squared, you can't just square the x and square the 3. You gotta remember, x plus 3 squared is just a shorthand for x plus 3 times x plus 3. And if you FOIL that out, you get an outer term of 3x and an inner term of 3x. They combine to make a middle term of 6x. The real answer is x squared plus 6x plus 9. Do not forget that middle term.
And our final tool is the zero product property. And honestly, this is the whole secret to finding out where our projectile is going to land. It's just common sense, really. If you multiply two things together and the answer is 0, then one of those two things had to be 0. There's no other way. So if our factored trajectory is, say, x minus 2, x minus 3 equals 0, we know for a fact that either x minus 2 equals 0 or x minus 3 equals 0. And solving those gives us our exact landing spots.
Okay, theory's over. You've got the blueprints. Now it's your turn to be the rocket scientist. This is your launch sequence. I'm going to give you 3 missions one by one. When you see a mission, just pause this explainer, try to solve it, and then hit play when you're ready to move on. Ready for launch?
Your first mission is a pretty straightforward factoring drill. Your goal is to deconstruct this thing into its two simpler pieces. So, what two numbers are going to give you the right product and the right sum? Go ahead and pause here and give it a shot.
All right, mission 2 levels things up just a bit. This time, you're finding those impact points. So you're going to have to factor the quadratic first, and then use that awesome zero product property we just talked about to find the two values of x where this thing hits the ground.
And for your final mission, let's see a real practical application. The area of some rectangular part is given by this quadratic. Now, to find the perimeter, you first need to know its length and width. So,
How can factoring help you figure that out?
Okay, how did that go? If you got a little stuck on any of those, seriously, do not worry about it. That's exactly what Mission Control is for. The next few slides have some hints to help nudge you in the right direction, not to give you the answer. Let's get you back on track.
So for Mission 1, really focus on the signs. Your product is a -12. So what does that tell you about the signs of your two numbers? One has to be positive and one has to be negative, right? And since they add up to a -1, which number should be bigger? The positive one or the negative one?
For Mission 2, just remember it's a two-step process. First, find those factors. But look closely. They multiply to a +15, but they add up to a -8. What does that tell you about the signs of your two numbers? Then, once you've got it factored, just set each piece equal to 0 and solve.
And for Mission 3, just think back to the basic definition of area. It's just length times width. So that expression, x² plus 7x plus 10, is literally the answer you get when you multiply the length and the width together. So if you factor it, you're just finding the length and the width. After that, just plug them into the good old perimeter formula.
And just like that, mission complete. Let's take a quick look back at what you just did. We started with the theory, you built out your entire toolkit, and then you actually applied all that knowledge to solve some real problems.
And here's the real takeaway. You're not just looking at a pretty curve anymore. You can now see the mathematical blueprint running underneath it all. You have the actual tools to take apart any quadratic path, find its core components, and predict exactly what it's going to do.
Look, from the simple arc of a basketball shot to the orbital path of a satellite, our world is just filled with these parabolas. And you now have the foundational skills to analyze them. So really, the only question left is, what path are you going to choose to explore next?